So let's take a look at this next section and answer your questions. Yes, there are 3 major stories that you'll hear throughout the year. The Eddie is the one of them. You'll hear the Halloween story right around Halloween, and you will hear the orange story. Plus, there's always tidbits that I throw in just when I think, hey, it might be kind of a good time to do it. We're going to take a look at, let's go back and kind of review a few things. So we talked about mean and median, right? That's supposed to be an A. Mean and median. The mean is the average and gets pulled left or right with the outliers. So things that are really small or things that are really big. The median is the middle of your data set. Okay? So that's what we're building. We're going to continue building with. So the mean, these are both called central measures of our data. Okay? Again, they aren't necessarily things that you need to go and change what you're doing with life, but they are good indicators of what did you represent. Really good places that you'll see mean and median are on the ACT and the SAT. There are other things that they talk about with those central things, but let's talk about a couple of new ideas. So the first one is the range. And all the range is the maximum subtract the minimum. So if you add your data, you look for your biggest value and you subtract your smallest value. Okay, so pretty straightforward. And I'm on page 16 in the book if you're following along with that. Okay, so the range just tells you, hey, this is where our scores took place. So if we were to take, let's say, just any math class, we're going to have probably somebody who has the top math score on the test or quiz and somebody who has the bottom math score. We can subtract the two from each other. The closer the range is, the more grouped together our information would be. The further our numbers are, the more spread out our numbers could be. Okay? It's always possible that you have a student who might be misplaced, where like everyone's getting like a 72%, and then you get that one kid who's getting 100%. Or you also have the kid that might be misplaced, where everyone's getting like an 86%, and then you get that one kid who gets like a 12%. Okay, those are just different ways of, thinking about the data, the min and the max. Again, the range deals with how spread out our data would be. It's the maximum data point versus the minimum data point, and the calculator does a lot of the work for you. But then let's see. There's something called the IQR, which stands for the Interquartile Range. The IQR is Q3 minus Q1. Like, okay, what's this Q information you're dealing with? So any piece of data, let me just put numbers up, 2, 3, this is just an example. 2, 3, 4, 5, 6, 6, 6, 6, 7, 7, 8, 9. Okay, just making up something. I don't know what we're representing, but normally your data doesn't come to you in order, though your calculator will sort it for order for you. So a few things I want to look at is I want to find Q2. Q2 is also referred to as the median. The median is the very center of our data. Okay, and there's all kinds of ways that you can go try and find the median. Just kind of come into the middle. I'm just scratching off one number on each side. And being I just made this up, my median happens in there. So theoretically, I would have to go 6 plus 6, which is 12, divided by 2. So I find that my median happens here, and I'm just going to show you the work that takes place for it. That's how the median takes place. Now, obviously, if you had two values and they're the exact same, if you add them together and divide by 2, you get the value back. But I just wanted to show you the work that took place, just in case it wasn't made up real easy by stirrup. Okay, now, for the interquartile range, or the Q3 and the Q1, what we're going to look at is this information, and Q1 exists in here, and this information. This is where Q3 is going to live. Okay? So the median, what it does is it breaks your data into half below it, half above it. It's the middle. Agree? If I wanted to figure out Q1, I'm going to find the middle of my bottom pieces of data. So I'll do the same thing with a highlighter, choose a different color. So I'm going to look here, 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 here. Oh, my Q1 lives in there. So I should add 4 and 5 together and divide by 2. 4 plus 5 is 9. 9 divided by 2 is 4.5. And that's our lower quartile, Q1. Okay? So you're finding the middle of the middle. You found the middle, median, the middle, broke our data into 2 different parts, found the middle of the bottom, which is Q1, and now I have to find the middle of the top. And again, I'm going to use the highlighter to emphasize this a little bit. So I went here, 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 here. Oh, this is where my Q3 would be. Now, this is obviously easy to tell me what Q3 is because they're identical numbers. But just to follow suit, we would go 7 plus 7 divided by 2. So that's 14 divided by 2, which is 7. And that is my Q3. Okay? Now, what Q1, Q2 being the median, and Q3 do is they separate my data into 25% portions. Below Q1, we have 25%. From Q1 to Q2, we have 25% of our data. Between Q2, the median, and Q3, we have 25% of our data. To the right of Q3, I have 25% of my data. Okay, so think of the quartiles. A quarter is 25 cents. So we're talking about 25%. So if we want to find our IQR, I'm going to go 7, which is Q3, subtract 4.5. What do we get? 2.5. Okay. So 2.5 is our interquartile range. So our interquartile range is the middle 50% of our data. Okay? Now, I'm just showing you how to do it by hand. I'm going to show you how to do it on the calculator as well. And again, I'm not trying to make you pros at the calculator at this point. I'm trying to get you to realize that it's a valuable instrument to use. And I will guide you along on the calculator if you need any guidance. Okay, so just a visual representation of data. You would have 25% of your data here, 25% of your data here, 25% of your data here, 25% of your data here. From here to here, that's Q1 to Q3. Okay? This region is the IQR, so you're talking about the middle 50% of your data. Okay? Right here would be where Q2 exists. Q2 is also called the median. Okay? And the reason why I'm saying Q2 exists, you very rarely see it listed as Q2 unless you're like looking at an old statistics book or an old mathematical guide. They didn't really come across the word median for some reason. They were like, you have Q1, Q2, Q3, but Q2 and the median mean the exact same thing. Now, somewhere amongst this range of stuff would be where our mean would exist. Now, our mean could exist right in the center. Our mean could exist somewhere in the blue or the green. It could even go as far as the pink or the yellow. Okay, it would happen in the pink or the yellow if you had some outliers that were taking place. But usually your mean, you want somewhere in that blue to green region. This would tell you have normal distribution of your data. Normal distribution just means half above, half below, forms a curve. Any questions about that? Okay. Other things that they might refer to is Q3, they might call the 75th percentile. Q2 would be called the 50th percentile. And Q1 would be the 25th percentile. A lot of times, standardized tests, whether they're ACT, SAT, medical exams, any of that stuff, a lot of times you'll hear people saying, hey, I scored in the 95th percentile. That means that you did better than 95% of all the other people on the test. 5% of the people did better than you. And where I kind of thought it was silly is my friend Rob Lieber, his sister is a doctor. And she was like this incredibly smart person, went to Brown University Medical School, took the doctor's test that they have to take once they're done with medical school. She was so frustrated that she scored in the 99.88 percentile range. One person in the world did better than her for being a doctor. She's like, oh, I got number 2. I'm like, how many people are you talking about? Oh, thousands and thousands and thousands. You got number 2? Yeah, God, I can't believe it. Get over it. She no longer practices medicine. I don't know what she does these days. I don't know why she gave up medicine. Yeah, like, go to medical school, get $500,000 in debt, and then don't become a doctor. Yeah, score number 2. That's it. I'm second best. I'm out of here. Do you want to know what you call the doctor that scores in the 3 percentile? You also call them doctor. Yeah, you don't want to be that. All right, so percentiles are basically how you think of a percentile as a percent. Q3 is the 75th percentile. Q1 is the 25th percentile. The median, or Q2, is called the 50th percentile. Percentiles can go all the way up to the 100 percentile, meaning if you're at the 100 percentile, that means you did better than 100% of the other people. Who did better than you? Nobody. Then they can break it down into different segments of percents. But then there's another thing. The final thing that we talk about is something called the standard deviation. Now, I'm going to show you the standard deviation equation. I will not ever have you write out the equation for it, but I want to explain to you what the information means in it. So standard deviation, they use the letter S for standard deviation. Oh, thank goodness something makes sense in math. And they have the summation of x minus x bar quantity squared divided by n minus 1. And you're like, whoa, wait, what? Wait. I get the square root sign. I'm good there, pal. Okay? This is the Greek letter sigma. In math, sigma means adding up. X bar is the average, or we call it the mean. X would be your score that you're referring to, and N is the number of data. So if you had 30 tests, your N would be 30. 1 just means I'm subtracting 1. Okay? There are 2 different standard deviations that come up on the calculator. We will always use what they call the sample standard deviation. And the reason we use a sample is because we're looking at a sample. The other standard deviation that takes place on the calculator is if you had created like a census where you had 100% of your information you're looking at. What basically happens is your sample standard deviation and your entire standard deviation become closer and closer and closer and closer the bigger your N value is, the more test scores you have. So if you wanted to like take a look at the scores of the SAT that they did worldwide, you might use the standard deviation based on the entire population. If you wanted to see how well like Cherry Creek High School did on the SAT, you would use the standard deviation that would have the N-1. So the sample standard deviation allows it to have a little more wiggle room. It goes a little bit further out. If you had, say, 50 pieces of data and you were finding the standard deviation by hand, it's a lot of work. It's not hard work, it's just tedious, it's out of control, and those are some things. So I want to show you on the calculator how to make this work. Let me go here first. Let me change that to arrow. So on the graphing calculator, I'm just going to make up some data. Let's go with ACT scores. ACT score, what's the top score? 36, yes? Yeah. Can you get a 0, do you think? I don't know. I think you get a 1 for, you know, if you exist, you get a 1. Yeah. So I'm just plugging in data. I'm just making this up. This means nothing. Unfortunately, I've seen those scores. I don't necessarily know who the students are, but I've seen those scores. All right, so I just plugged in, looks like I put 24 pieces of data. I just made it up. I arbitrarily made it up. I didn't put it in any particular order. I'm not gaining this data from anywhere on the worksheets. It was just in the world of Stirrup's head. You okay still with that? So with this information, I don't need to make a box plot or a histogram or anything like that. All I want to do is I'm going to go into stat. I'm going to go to calculate, and I want the one variable statistics. The difference between the one variable statistics and the two variable statistics would be, let's say I'm comparing ACT scores in list 1, SAT scores in list 2. The two variable statistics would find each of the individual, information. So I'm going to look at list 1. I'm going to calculate it. So this gives us a lot of good information. This right here tells us, with the data that came up in Stirrup's mind, that we had an average score of 19.625. Okay? If I were to have added up all of my scores, I would get 471. If I decided to take 471 and square it, I would get 11,499. But then the next thing that we come to is SX, and then this weird little Greek sign X. SX is the standard deviation we're going to use because it was of a sample. This other standard deviation is the entire population standard deviation. The difference between these with the equation, this had the n-1 as the denominator. This has n as the denominator in the equation I just showed you. Okay, we're going to stay with the sample standard deviation. Notice they are a little bit different. Okay, and that's okay. But again, the more data I get, let's say I put in 200,000 scores into this, which I'm not going to do because it's going to take a little too long to do. All right, come on, Stirrup, do it. No, I'm not going to do it. If I put in, say, 200,000 scores, these two numbers are going to get very close to each other. Okay? Now, what the standard deviation means is how far would you be from the average score. Now, there's some other things up here and I want to talk about, and I'm going to write some of these down. Or actually, will someone do me a favor? Will you write X bar is 19.625, please? Will you write SX is 9.90? Will you write minimum 7? Will you write Q1 11? Does anyone who's ever scribing for me, will you let me know? The median, which is also called Q2, is 17. Q3 is 28. Okay? So between Q1, this means that 25% of our scores were below an 11. Q3, this means 25% of our scores are above 28. Between Q1 and Q3, 50% of our scores exist, including our median. Our maximum score is a 36. And that's all the information. So did somebody write that down? Please tell me if someone did. You got it? Okay. So this is going off the cuff a little bit, but that's basically how you do this. Let's see. It says in the notes, it says the standard deviation cannot be a negative number. If the standard deviation is 0, that means that every observation in the data must be the same. So there's no deviation. The standard deviation is the measure of spread, but more specifically is an attempt to capture the average deviation from the mean. With data sets that are more spread out, the standard deviations will be higher. The standard deviation is higher dependent upon both the mean and the distance each value is from the mean. Therefore, the standard deviation is not a resistant measure. Extremely high and low values will have a significant and often unfair impact on standard deviation as a measure of the spread. And then your graphing calculator, as we just did. Okay, so this is what this means, and this is not for necessarily today, but I want to talk about real quick the normal curve. Okay, so this is just basically a normal curve. Basically, this is the x-axis. This is where our scores fall. Notice at the ends, I don't touch the x-axis. The x-axis becomes something called a horizontal asymptote, which I imagine you have heard at some point in your life. Okay. Somebody who did the information, what was the average X bar? 19.625? Okay. What was our minimum?
7.
And just because I'm on the task, what was our maximum? 36. What was our Q1? What was our median, which is Q3, or Q2, excuse me? 17. What was Q3? And then what was our standard deviation? 9.90. Okay. So on a normal curve, this is basically our mean, 19.625. Okay. Our median, if we wanted to make this a normal curve, our median is, so that's that information. Our median is 17. 17 is to the left. Agreed? And I'm just going to label that Q2. So what that basically means is I had scores higher to the right. I have some outliers that are pulling it. I had a maximum score of there of 36. Though we had probably a low score of like a 7, I think I put in there. I didn't go all the way down to 1. So that 36 is pulling the mean to the right. Okay? So the standard deviation goes each way. Somebody have a calculator handy? So if you have a calculator, will you go 19.625 plus 9.9? 525?
Yeah.
Will you do the same thing? 19.625 minus 9.90? 9.725. Okay. You still have the 9.725 on your calculator? Will you subtract 9.90 from that again?
So 9.725.
Minus 9.90.
Negative 0.175.
0.175. Okay. Will you go 29.525 and then plus 9.9?
So minus 9.9 is 19.625.
Okay. But go plus 9.90. So 29.525 plus 9.90.
Is 39.4.
Okay. You can indeed go out 3 standard deviations each way. Okay, but highest score on the ACT is a 36. Notice this score is outside of it. So looking at our data that was made up in Stirrup's mind, our highest data was a 36, which is somewhere in between these two numbers, right? Between 29.525 and 39.425. So 36. Our lowest piece of data was a 7, is that right? I think you guys had commented on that.
Yeah.
So a 7, this is 9.25, so we're somewhere down here. What this normal curve basically refers to, let's look at other information we put. So our minimum score of a 7 is here. Our maximum score of a 36 is like right here. That's our max and our min. Q1, which is 11, is about here. Our Q3, which is 28, is about here. Our median, what's here at 17. Okay, so this is what a normal curve looks like. This information tells us all kinds of things. Our x-axis can go from 0 to 100 if we wanted to break it in percentiles. I think some of you might have taken an AP test, right? So an AP test, when they test it, is this. The lowest score you get in an AP test is a 1. You get a 1 right here. A 2 is here. A 3 is within this region here, these two regions. A 4 is here. And a 5 is outside of it. Okay? They renormalize, from what I understand, they renormalize every year AP test. So they grade it. They have the same kind of grading rubric where you have, okay, this is a 4-point problem. These are the things we're looking for in this 4-point problem. This is a 6-point problem. These are the things we're looking for. And basically, I mean, AP grading is pretty tedious. I would grade the AP test. I have all these AP tests in a stack. I push them to the person sitting across the table from me. They grade them. If there is a discrepancy between my score on any problem and their score on any problem, there is the master grader who comes over and takes a look, saying, okay, Chris, why did you decide this? And other person is grader, why did you use this? Then that master grader gives the overall score. Okay, saying, oh, Chris, you gave 3 points for this problem, you gave 4 points for this problem. I understand what Chris said, I understand what you said, but I truly feel that this would be a 4, and my grade get overrated to help the kid. When they grade AP tests, they usually do it in Kansas City, and it's I don't ever want to be a grader of AP tests because I'm sorry, sitting there and grading tests all day for like 3 days in a row doesn't sound like a lot of fun to me. But they treat them well, they pay them well, they get all their meals and their hotel and everything's covered, their flight to wherever they went is covered. So that's all part of it, but it's just tedious work. But I guess you understand what's on the test and how they want to grade it as a teacher. So if I was teaching an AP course, maybe it would be a benefit for me to be there, not that. Let's see, what else do we have? We have about everything on here. Okay, so again, my friends, I am not ever going to have you find the standard deviation. I will say find on calculator only. Okay, and it's the SX for the sample deviation, not the other Greek letter one. Okay, did I do okay? Any questions for me?
Great job.
Go ahead.
Great job. Could you explain how to find the IQR, or do you find the IQR off calculator?
So the IQR, the calculator won't give you. It's just going to be Q3 minus Q1 every time.
Yeah, so it's the middle 50% of the data, right? So it's like for the first problem there on IQ, this is data, so would it be like 9, right? Would it be like 9 in the first 9 would be, I don't know how to explain this.
Which one are you looking at? I'm sorry. On the homework or?
Yeah, 1, 7.
Once, yeah.
1, 7 in the homework. So for number 1, it says calculate the range, the IQR, and the standard deviation. And then for the IQR, you would count all of those dots as pieces of data.
So it looks like there's 21 pieces of data.
Yes.
That means let's find the 11th number. And you always start from the bottom, okay?
Okay.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It looks like 10.4 would be the median.
Mm-hmm.
Okay, so that was the 11th piece of data.
Yes.
So if I have 11 pieces of data, I'm not going to include that. So I'm going to go from first to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to take the 5th and 6th. 1, 2, 3, 4, 5, 6. So the Q1 is, they both fall in the 10.3. So the Q1 is going to be 10.3.
Okay.
Because you go 10.3 plus 10.3 divided by 2, which is still 10.3.
Yeah.
And then I'm going to do the next 10. So I'm going to go the 5th and 6th. So 1, 2, 3, 4, 5, 6. 5 and 6 also fall in the 10.6. So yes, you could go 10.6 plus 10.6 divided by 2 and still gets 10.6.
Yeah.
So you're going to go 10.6 minus 10.3, which gives you a 0.3 IQR.
Oh, yeah, okay. Got it.
Okay. Calculate the range of the IQR and the standard deviation. So from that information, what I would do on the calculator is I would do it exactly like this. Let me take this back. Where's my, I want to go here, here. If I were to plug that information in, I'm going to go stat, edit, move it up, clear, down arrow, and I have 10.1, 10.2 3 times. Oh, crud, stat, edit, 10.1, 10.2 3 times. 10.3 4 times. 10.4 5 times. 1, 2, 3, 4, 5. Oops. 1, 2, 3, 4. That needs to be 10.4. 10.5 twice. 10.63 times. 10.7 and 11. So I have the 21 pieces of data, like we said. From there, I'd go stat, calculate one variable statistics for list 1 that we used. So you have an average of 10.42, standard deviation of 0.21. You could round it to 2 decimal places, it'd be fine. A minimum, or you had Q1 is 10.3 that we said. The median is 10.4, which we said. Q3 is 10.55 for some reason. Oh, wait, we have 20 pieces of data and there's 21. Shoot, stat, edit. I messed up on my data, but that's basically how you do it on the calculator. Definitely go through one variable stats and then go from there. So 1.7, which is 113. to 115. So, and I'll give you some time in class tomorrow. So we got 113 to 115. Do 20 minutes into the period tomorrow. Does that sound fair? Cool. All right, I'm going to stop recording unless there's any other things you need me to say, do, help you with, laugh at, point at.